Yes,
Dr.
sir.
Ganesha Balamurugan? Yeah, we can
Yes,
start
sir.
now, isn't it? Yeah, fine, sir. We can.
Okay, sir. Uh, Morning, madam. Please start.
Start பண்ணிடும்.
Good morning, everyone. Ladies and gentlemen, let me first thank the Lord Almighty who has preserved and protected us. Warm greetings to the excellent intellectuals, professors, faculty of various universities and institutions gathered online today for this CSIR sponsored online 2 days national level seminar on challenges and opportunities in 3D printing and design. This program is organized by the Department of Mechanical Engineering, IFT College of Engineering, an autonomous institution in Viluppuram, Tamil Nadu.
The way to start a successful day is to have a warm welcome. I now invite Dr. K. Ganesha Balamurugan, coordinator of this function, IFET College of Engineering, to deliver the welcome address. Over to Dr. K. Ganesha Balamurugan.
Thank you very much, sir. Good morning to all dignitaries, staffs, and participants. This is an immense pleasure to welcome you all on behalf of the Department of Mechanical Engineering to our 2 days seminar on CSIR sponsored challenges and opportunities in 3D printing and design. I'm glad to welcome our respected chairman, Mr. K.V. Raja, the nucleus of the driving force in pursuit of excellence. I cordially welcome our secretary, Mr. K. Shivaram Alva, the motivator, passionate as we reach greater heights. I cordially welcome to our treasurer, Mr. R. Vimal, dedicated in the mission to transfer knowledge. I also welcome our principal, Dr. G. Mahendran, and vice principal and dean academics, Dr. Matilda. All for this seminar, almost 135 participants have been registered, and this seminar is about 3D printing. So why we have chosen this topic? Because 3D printing is the present and future. So it ensures the design freedom, which makes a paradigm shift to the present society for future endeavors. We are fortunate to have an eminent expert in this field as speakers. Mr. Kumar Ramirez, CEO and President, Rights and Boards Labs, ASA, Mr. Anand Kumar Mishra, Operations Manager, Three Textile Education Private Limited, Dr. Mamilla Ravishankar, Associate Professor, Department of Mechanical Engineering, IIT Tirupati, and Dr. Manivannan, Scientist, Additive Manufacturing and Metrology Group, CMERA, CSIR Group. We are honored to have their lecture in this seminar. Dear participants, I assure you, this seminar will surely delight you, and at the end of this seminar, you will gain a fruitful knowledge and understanding about 3D printing. Once again, a cheerful welcome to all professors, faculties, and students of various universities and institutions to this online knowledge enhancement program. Wish you will all enjoyable online learning experience. Thank you. Uh, I have to give one information. Uh, Please, everyone, to mute your videos and the audios for uninterrupted presentation for everyone. And at every end of the session, we will share our attendance in a Google form in CSC in our WhatsApp group. So kindly you have to fill it for the certification purpose. Thank you very much.
Thank you, Dr. Ganesha Balamurugan.
I now invite Professor P. Velmurugan, HOD Mechanical Engineering, IFT College of Engineering, to deliver the inaugural address. Over to Professor Velmurugan.
Good morning, all. I think I can be heard. Yes, fine. So good morning all. I feel very privileged to be a part of this 2 days program on 3D printing and designing sponsored by CSIR. 3D printing, also known as additive manufacturing, is a method of just I have is a method of creating a three-dimensional object layer by layer using a computer-created design. So 3D printing is an additive process whereby layers of materials are built up to create a 3D part. This is just the opposite of subtractive manufacturing process where a final design is cut from a larger block of material. So as a result, 3D printing creates less material wastage. So this technology is already changing the way we produce objects from tools, toys, clothings, or even our body parts. So as a spare. So the spectacular thing that has happened in recent day was 3D printing was extensively used in building up the rocket that was launched by the SpaceX. So additive manufacturing also allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller consumer-friendly 3D printers are bringing additive manufacturing to home and business. So, which is further adding on to the fun of engineering. In olden days, 3D printer was preferred to create prototype mostly using a photo polymerization technique. So dating back to 1920s. So thanks to the evolution of the laser technology, which dramatically changed the applications of the 3D printing from prototype to real-time manufacturing. So the advantage of additive manufacturing is that there is no process planning required as in the case of conventional manufacturing, and even more advantageous only if the product is intricate in nature. So it is advisable to go for conventional manufacturing method if the product is simple in nature with respect to the shape and material. The real challenge lies in the additive manufacturing, producing the part with lesser lead time, printing the metals and alloys with no defects. So our students even took up this challenging opportunity as an academic project. So one of our students printed the biodegradable water bottle few years back. So the difficulty he faced was to print the 250 ml bottle. So in those days, it took almost 1 day using this FDM technique. So for the past 2 years, our students have been trying to build a low-cost, customized 3D printer using e-waste. So and uh, actually we are indebted to our speaker today, Mr. Kumar Ramirez, for having rendered this support by offering internships to our three of our students. So who have
It's okay, sir. We can proceed, sir. You can proceed. I think I have got a break. Okay, okay. Thank you, Professor Velmurugan.
It's time to begin the first session of this CSIR sponsored online 2 days national level seminar on challenges and opportunities in 3D printing and design.
Now it's time for introducing our resource person. I now call upon Professor Ilamalidi to introduce the resource person, Mr. Kumar Ramirez, CEO and President, Whites and Bats Labs, IEEE Southern California Council, and Chair STEM Educational Outreach Programs. Over to Professor Ilamalidi.
Good morning to all. It is my privilege to introduce Mr. Kumar Ramirez, CEO and President of Whites and Bats Labs, IEEE Southern California Council, Chair STEM Educational Outreach Programs. Mr. Kumar Ramirez had a short teaching career at the University of California, Irvine, and California State University, Long Beach, in the field of educational technology and information systems. He then worked in IBM for 9 years. Mr. Kumar Ramirez became an entrepreneur in the year 2009. He is the founder and chief education officer of Bytes and Bots. He is currently involved in the following enterprises and educational activities. IEEE Southern California Council Chair STEM Educational Outreach Programs and co-chair of International Science and Engineering Fair, ICEF 2020, Anaheim, California, and Anaheim School District STEM Program and Service Advisory Member, and a member in Association of California School Administrators and Partners in Educational Excellence Award winner. STEM Advisory Board member of IVC, OCC, and Saddleback College. Mr. Kumar Ramirez is provider of Makers Lab and custom 3D printers. He has been a California resident for 3 decades, and Mr. Kumar Ramirez interest includes mountaineering, grape growing, and winemaking. He is a certified wine educator and a sommelier. So we are very happy to have such an eminent person with us today. Thank you, sir.
Professor Elamarudi. I now invite Mr. Kumar Ramirez, CEO and President, Bytes and Bots Labs, IEEE Southern California Council, Chair STEM Educational Outreach Programs, to take over the session.
Hello. Hi, thank you, everybody. Do you need my video, or video is not needed?
It is up to you, no problem, sir.
You can share. We are always welcome.
All right. Okay. Very good. So thanks, everybody. And for me, right now, I'm in California in our lab in the city of Irvine. The time here is 8:50 p.m. It's just after dinner. I'm joining all of you. It's a privilege and honor to talk to all of you and share my experience in this industry, 3D printing for education and innovation. I just wanted to ask a quick question. Oh, but can I start the presentation of my PowerPoints? One second, let me do that.
Yes, sir. You can share your screen and start it.
Okay. Are you able to see the screen? Oh, one second. One second. Okay. Are you able to see my screen?
Yes, sir.
Yes. Okay. Very good. Just wanted to find out how many of you are. Are you all tuning in to this presentation from Tamil Nadu, or anyone from outside of Tamil Nadu, and you don't you feel comfortable with my language? Is everyone English and Tamil speaking, or we also have other language speakers in this?
I think most of the majority of audience are from Tamil Nadu. We are able to understand.
Okay. All right. Okay. I'm not going to go over the videos. You can Google them and watch them. What we're going to cover in this presentation, what is 3D printing? In the intro, some of the faculty members talked about that a little bit. With the focus on education and innovation, how 3D printing technology has been evolving and are being embraced and used by individuals, hobbyists, educational institutions, from elementary to secondary to post-secondary educational institutions across the world. And it's the inherent nature of supporting how it enables curious minds to make new things and take an individual's creation to global market across the world. We'll talk about that. Some basic information about the different types of 3D printers, what are the different components of a 3D printer, and what can you do with it. Since I'm talking to all of you from California, this is holiday season, Christmas and New Year. There are stores. I'm sure one of the popular gift items parents will buy or aunties and uncles will buy for their children will be a 3D printer from a local tech store so that the kids can draw stuff on a computer and then print it and play with it and have fun with it. That being said, let's move on to our own lab. From an idea that you conceive and you digitize that idea by using a CAD software and saving that off in a file format and printing it. So this little short video here is showing.
Let's get some practice designing a machined part like the one you see here. Now you can see that for the most part, it's made up of extrude features, which added the geometry and removed geometry for the pockets and cuts, as well as some fillets to break the sharp edges. Now let me switch over to this other part studio to get started. For this example, I have a sketch already created. The two-dimensional geometry here can be created in Onshape using the various sketch tools and constraints. But for this example, I'd like to show you how you can leverage a sketch like this that contains multiple sketch profiles to create the 3D geometry for the part using various features. To get started, I'll extrude the main body of the part. I'll make sure all of the sketched geometry is deselected and select the extrude icon from the toolbar. I'll select the interior profiles to create the geometry for the body of this part.
I'm going to fast forward that for a moment. So let's move on to this video. So here, digitization of your idea of a product creation using a CAD tool on the computer and then sending it to the printer. So whether it's a coffee maker or a cup, or say I have my pair of glasses and I wanted to personalize and use my own design to design and print the frames for my glasses, I can do that in a few hours and make a one-off product that is designed and created for my glasses that fits my face profile the best possible way. And that's pretty cool to do. And you don't have to be an engineer. You don't have to know everything. Just you're able to Google most of this and even download an existing file and modify it. If you have the computer-aided drawing skills, then you will be able to print it and wear that on your face. The next example, we have a 6th grader in one of our labs where she's doing biomimicry in this. And that bionic arm project was designed digitally and then printed, and then she programmed using Arduino and open source hardware. I'm sure many of you are familiar with that. And what has done this for this young girl that is working in our lab, it has inspired her to become a future engineer, that not because her parents told her that she should study engineering, but because she became interested because of 3D printing technology, and she understood it is a pretty cool and fun thing to do. Okay, so let's move on to some of the other examples in different industries. And in fact, you are able to see right behind me, there are a couple of 3D printers that are actually printing right now. Right there, there is a 3D printer that's printing an object, and it'll run overnight and print. I'm not sure what it is printing. I would have to ask the engineers, but it is doing something right now. Okay, so let me go back to, I'm going to show you a 3D printed V8 engine model. So it's a time lapse, and it's showing it at a higher speed of the whole extrusion of and building and print as it is printing it. So the end product here, after it prints, and here is a functional prototype of the pistons, and with a simple drill that they are simulating that. Again, how cool is that? And then another quick Toyota car company's model. Somebody earlier during the introduction mentioned that it is used in the space station. It's used in space technologies. It's used in every aspect of life, anywhere from making some fun toys to serious one-off production quality that you can actually use it and fix issues. So I'm going to pause this. So again, a few years ago, this will require a lot of fund, a lot of resources, people, and their time in order to make a one-off functional prototype to test something. So for me, this is an amazing thing that has happened from our traditional manufacturing world. How many of you have made a Ganesha statue for Ganesha Puja? yourself, or you just go to the market and buy a clay model of Ganesha. And that is an example of traditional manufacturing, making a statue of Ganesha using clay, or making a pot that you use for cooking. And then you move it to the next level for industrial type of mechanical engineering type of applications. And in the picture that you see how complicated and unwieldy heavy equipment and machinery are needed to manufacture materials, prototypes even, whether it's functional or non-functional prototypes. And the amount of waste products that get extruded when you are making traditional manufacturing used applications, you will have a lot of debris, an environment that is not clean. And it causes pollution. These materials can go add contaminants to water resources and our land. But with 3D printing, you can specifically design, and because it's additive nature, you're able to reduce all of those pollutants in the environment. So dirty manufacturing is becoming history. Now, what's in a 3D printer? Well, for a beginner, and that's my topic here, and you are using this in the world of education. Say you're in your college and you are teaching an engineering subject or a product design subject, industrial manufacturing type of subject, where instead of talking about all of the dimensional aspects and the physical and spatial aspects of that project, you can actually quickly ask them to draw it on a piece of paper in an analog format, and then evolve that on the next step to digitally design it using a CAD software, and then quickly print that object and test it. And when you are studying business MBA programs, they talk about a concept called fail forward. Fail forward is very much possible. And in fact, you can quickly fail and quickly fail forward so that you learn from your mistakes and you are able to update the design, make it more viable, correct all the mistakes or errors, and then make your product in the first 1 or 2 cycles a close to finished functional product. Okay, so and it is using very simple components as part of the 3D printer machine. You can make a 3D printer machine in your own house. In fact, here a lot of people in their garage workshop, they have a little garage. Garage means typically in America, you park your car, you have some repair or change your oil in the car. You're able to do that in your garage, in your workshop. You don't take it to a typical car mechanic shop to do that in most cases. Okay, of course, as we Indians that we live here, we don't want to get our fingernails dirty, so we don't do that, but most Americans will do it. It is a garage-based culture. So 3D printing has enhanced that, and it is a beautiful thing. And their kids also join the dads doing that in the garage, and then say, okay, let me also join you doing that. So engineering that natural involvement of students, young children getting involved in the making process. And then how is it relevant for innovation? We'll also talk about that. And there's a little anecdotal story that I wanted to talk about that. Okay, so as part of the 3D printer machine, there's an extruder assembly, and there's a hot end nozzle. Let me actually walk over there to show you that. Hopefully the camera can. You probably have seen it. And let me see. So on this, so there is a printed object on the hot plate. This plate here is the plate where the layering occurs. And here is the extruder assembly. I hope you can see it. Here's my hand. I can show you that. And then the filament is coming from here. There are different colors you can switch. And nowadays there are 3D printers where you can have multiple colors extruded via multiple nozzles here. And then also you can see one that is printing some sort of a specific component for a research and development project. Okay, so this lab all around here has different types. So here's an R&D. Somebody's building a 3D printer here using some locally sourced materials. And there are different types of 3D printers. I hope you can see that. So this is a Delta type of 3D printer that is being built in our lab as a prototype, meaning a printer to print a printer. And that's pretty cool. There's actually a Hollywood movie actor that said once, here are some more. So I'll go back and take my seat. So that person said, go to the store, buy a 3D printer, come home, print a 3D printer, and then return the 3D printer. Does that make sense? I think that is pretty cool. You buy a 3D printer, bring it home, and design your own 3D printer and print using the 3D printer, and then return the original one that you bought in the store and then get the money back. Of course, that's possible in the US. You can return things and get full refund, but in India, you may not be able to do that. Just a side note. Okay, so that's I thought that's pretty pretty fun. Let me go back to. Okay. Are you all able to see my previous slide that I was talking about? Then, but instead of the picture, I actually showed you the printers where it's printing and some are being assembled. So there is also the brain part of this 3D printer, which is a controller board, and where you can customize it. You can write your own code and upload to it. And make a 3D printer that suits to your approach and your lab or whatever purpose that you're doing that printer for. And any moving locomotion aspect, the X, Y, and Z traversing of the nozzle head or the extruder assembly, they're all provided by the stepper motors and the stepper motor controllers, and the operation of the pulleys and wheels and belts. So there is a controller, and we make our own controller in our lab, and modeled on an open source specification. And again, as you saw, some of these specific aspects of that. And the different types of 3D printers we have, Cartesian, Delta, Polar, Scara. You saw some of these models as I was walking around the lab and showing them to you. And what about the nozzle size? So that the layering, the slicing of the melted extruded materials, so that you can have the fine grain control of the printed object. And here's a little animation. So there's a motor, hot gear, heat sink, and there's a thermistor to sense the temperature, because it has to, the thermistor will provide the control for the temperature control and manage the temperature. And by the way, I was in India. A few years ago, I visited all of the major 3D printer manufacturing companies in China. And also from an end user point of view, there's a place in Auroville where somebody got a 3D printer. And then another industry there's an industrial estate near Pondicherry I visited. And guess what? They have 3D printers, and they were very happy that it worked for the first 3 or 4 projects. And after that, it got stuck and nobody was able to fix it. And they got tired of it because it never worked after that. That is a major problem when it comes to 3D printer. It's not like your regular paper printer. You use the laser printer where you can print something on a piece of paper, and even somebody that doesn't have any technical skill or knowledge can open, change the papers, and put the ink cartridge, and you can continue with the business of printing. But in this one, 3D printers need, on a regular basis, proactive cleaning, especially the nozzle. All of the frozen materials will clog up. And that means if you're not interested, if you're a regular user, then you are stuck. And that's exactly what I saw. And a lot of my friends here, they actually bought a 3D printer for their kids. And like I said, it prints a few objects. And after that, it gets dirty. And then the printer is not being used. So you have to be a lab monkey in order to actively use it and work it so that you find the benefit of it. Coming back to that slide trip on the consumer-based 3D printer use and what happens to that one in the market. Like I said, you use a hardware and then typically written in C, and you have a controller program that provides the brain and logic function, controller function for your 3D printer. Okay. You can buy a 3D printer here in California anywhere from like a, $75, $80 for your kitchen countertop use versus multi-million dollars, where you can print a beautiful pair of shoes. Nike, the company, the shoemaking company, they are investing big time in printing shoes with the right amount of air pocket, so it provides great cushion. You can design, they will send you a template. You can go to Nike's website and draw your feet using that template, and then upload that design of your feet, both of your left and right foot sketch, and then they will make the specific pair of shoes that work for your feet. And what is that? And that is what Industry 4.0 is. And we'll talk about that a little bit in one of the later slides. Now coming back to when you print an object, It is not going to print things in the air. It is needing some sort of a support, especially there are some overhangs. You're printing a tree. It has leaves that are hanging, but those leaves need to be extruded and layered and printed. So it will print supports for that. And then later, as part of the post-processing, you will remove those. And then the slicing is controlled. Slicing means every individual micro level layers with the right amount of fills so that you can control the density, strength, etc. with that. So filling is something that you need to control. There are job opportunities where 3D printing companies, bureaus, hire people that specifically work on what type of fill is needed in order to efficiently print a prototype. Okay. And here is a one-off that needed the support. So you wanted to print this nut, a screw, and so you need to design that and then also tell the 3D printer, oh, you need to have these types of support so that the extrusion will go smoothly and you will have the end product for that. And you have to configure that like you will configure regular printer to do that. In the printer configuration software interface, you can do that. And let's talk about the different types of materials. There's PLA, ASA, PTG, some of the popular materials that are used, and it's showing the examples, how much strength it can take and when it'll break. Your typical elemental strength analysis, all of those things can be done with the amount of power test that you do. And there's also a long list. I heard even recently they are sourcing coconut fiber from India and the Philippines, and they are using that as part of the extruded material and making that so that you can make environment-friendly materials. And this slide shows some of those examples. When it comes to prototyping, prototyping for industrial use or prototyping for your own personal hobbyist or fun use, all are possible. Remember at the time, when you went to the tailor, say I'm 55 years old, back when I was in Tamil Nadu, before I came to the US, before I went to college in India, when I was, say, 7th grade, before Deepavali festival, my dad will take me to the store, the streets in my hometown, and we'll buy the fabric, the cloth, and then you'll go to the tailor, and the tailor will measure your body, and then he'll say, come back after 1 week, and you will get your custom fit, custom tailored shirt and pants. Now, you can do that to design, customize your own car that is street-worthy, meaning that you can drive on the road. It is not a fun, cool toy that the kids play. It is actually you and your family that can sit in the car and drive on the road and get to a destination safely and get back home. And that is called individualized mass manufacturing. What is that? Individualized mass manufacturing. How creativity and innovation can play a major role. creativity and innovation can feed into that cyclical, perpetual creation of more creativity and more innovation. Okay, so remember I said you go to the tailor and he measures your body and then he custom fits that particular shirt and pair of pants that you wanted to wear, and that's individual need, right? You are making your own shirt by paying that tailor who measures your body and does that. But as we move from that is, I'm talking about almost 2 generations ago that happened, but it is coming back. How is it coming back? Because of 3D printers. Because 3D printers can individualize at the same time mass manufacture. A student from your college, your university engineering department can dream up a beautiful product that solves a day-to-day problem. And he designs it and he can 3D print, and then he can scale it up and mass manufacture it and sell it to the world. And then go to the next step is, okay, so now you wanted to customize my generic type of product with your own logo, with your own name, maybe with your picture, and you can let people do that customization, which is fun for them to do. And how about this? You can actually 3D print a dosa or a birthday cake, and say your son or daughter is having a birthday party, and we have a 3D printer that can print pancake. Pancake is roughly the equivalent of dosa in South India. And it prints pancake based on the design that you created on the computer, and you uploaded it onto the 3D printer's controller program. And then now you have a customized pancake with, say, a star or a bunch of balloons flying on that with different colors embedded, that is creamy layered and that is still edible, and it makes that kid feel happy because it is highly personalized. And then it is individualized, and you can also mass manufacture that. And then when I visited one of the biggest manufacturers of 3D printers in China, Tier Time is that company. The amount of emphasis and the encouragement the government gives. Xi Jinping personally visited the inauguration of that company, and they are providing enormous amount of support in quality manufacturing of the 3D printers, including metal 3D printers, because they are focusing on intelligent manufacturing. So we talk about additive manufacturing, rapid prototyping, or advanced manufacturing. But what about intelligent manufacturing, just-in-time manufacturing? If on the space station, International Space Station, a particular part is broken because Elon Musk's company shipped a couple of 3D printers and they are sitting there, and all that they have to have is a design uploaded from Earth, and then the astronauts on the space station can print and fix the problem. It could be the hinge on the door or a nail that came off connecting two sheet metals. You can make that happen, and you don't have to worry about the door flying off into the space. So that is the power 3D printer gives people, anywhere from any individuals, even children, small children that are learning math and science, you can do that. And how can you use this to teach math? It is all about geometry, right? 3D is geometry. And mathematics is the expression of symmetry. So symmetry is the key in mathematics. So if you are able to connect that concept and make them design that on the computer, they will readily understand without going into the theoretical memorization, and they will be able to actually print that and see it function, and you have the aha moment, and that student will never ever have to memorize mathematical formulas, and he will be able to learn it hands-on. That is, I call it hands-on, applied, real-world based learning. You don't have to lecture them using a whiteboard, but you can rather have them discover, fail forward, and become an innovator, become a problem solver for a better tomorrow. And this example, the European Space Agency actually used this a functional, it's not a prototype, it is a production